Okay, thank you. Thanks for the invitations, and I'm gonna give you a presentation about the wolf population status in France and what's going on the French side, and especially how the monitoring can highlight the decision-making process. So I'm sorry not being able to do the presentation in Italian, so I hope it will be fine for everybody. So the scientific knowledge can be used for management purposes in three ways. The first one, of course, which is important for protected species like the wolf, is to appreciate the species conservation status. So then basically this is to say if the population is increasing, stabilizing, or decreasing. The second point could be to deter some relevant factors explaining one spatial biological system, and once we can identify such factor, then the manager can act on that factor to change the output of the system. And the third point is also to give some risk analysis to the manager that has to consider a management option, and then we can provide a risk of having a population decline or population increase. So of course, whatever the objective of the monitoring, all monitoring system needs to have good and standardized field data. So this is the key point, and especially on wolves, because as everybody knows, wolves can move very far when they are dispersing for 100 kilometers for a few weeks, and they are living in large territories. So, of course, the monitoring cannot just rely on a few specialized people working in the mountain with their binoculars to see if there are some wolves around. So we can't count wolves like that, of course. So here, this guy is saying, do you see something? And the other one is just answering, no, shy by 0. Of course, I would say, yes, you should write 0, but not because the animals are not here, but just maybe you didn't detect them. So that's one of the key points you have to account when you monitor such kind of species. And what we choose to monitor the wolves over large scale, this is like finding a needle in a haystack, of course. So what we choose is to gather a lot of people, like a lot of field experts, all around the different districts in France. You have the map here. And to cover all this area, and especially the colonization area in yellow here, and then dispatch all these field experts all around the space. So these experts are from various origins, and this is a very important point, but mainly they are professionals from wildlife state organisms, governmental organizations, also from forestry office and landscape protected area technicians, of course. But also we have in the network of people, some of them are shepherds, are sheep breeders, are hunters, also wildlife defenders, and some local people that are selected in different places to fill some gaps that we could have in the preservation efforts. So that's a very important point, and that kind of monitoring could belong to what we call the participative science, but not as every citizen can just report on a website every information without controlling the robustness of the data. Okay, so we want to control the quality of the data that enter into that network, and that's why this is a lot of work, but it's the price to pay to train all that people, that's 3,000 people now, for training sessions just before they enter the network. So we are organizing all these training sessions almost everywhere, so this is a huge work. but also very important to gather. When you have to gather the data, people are working in the same way with the same data, and then you can make a large file and analyze it. And of course, this network is not working alone, and we are connected with the other countries. So mainly Italian, Swiss, Austria, Slovenia now, within the WolfAlpine group, and Francesca told about that, so I will not enter into that point. And then all together are using different techniques to monitor the wolves. So this could be with camera traps. This could be also to keep in touch with local people and then being able to control for wolf sighting, for example, or wolf strike that somebody can find somewhere. Using wolf howling in summer and also snow tracking in winter, of course, together with a DNA tool like non-invasive molecular tracking, and also to control each depredation that can occur all over France, so, which is quite a big deal in France, but I will detail this point later on. So back to the science in practice for the management purpose. So the monitoring is defined within the National Action Plan in France. That is working for the period 2013 and 2017. And three main points have to be implemented. The first one is to increase the detectability of the species in new area of colonization. The second is to increase the reactivity in modeling the distribution of the species and the demography. And then the third is to refine the demographic modeling approach, so being able to model the population dynamics. And then all together, all this data can be computed into a single database, being able now to draw maps of the trend of the species distribution. So starting here in the early 90s in the very southeastern part of France, in Mercantour, and then colonizing northward in the Alps, up to now where we have wolves almost all over the Alps, and also in the northeastern part of France, in the central part of France, even in Pyrenees, with some occurrence in between. So then, here is the update of the population in number of packs. You have it in black here. So we can get, thank you. We census 30 packs, and together with 12 other single wolves, each holding their own territories. So the population is still increasing and colonizing on the French side. So the wolf is present. In different landscapes, as you can see, from high mountains up to lowland area. And I think this is a point that is not very clear for everybody, but usually we can hear some people, some general public, saying that the wolf is living only in special place, special protected species, far from human, and so on. And maybe it's good to say that if there is one species that can live everywhere and adapt to everything, this is the wolf. So for the second point, that to find some factors that explain biological mechanism, we can take the example of the wolf-livestock interactions, and which is a very big deal in France, and you can see it on that graph, where you have in blue here the number of attacks we have each year that reach more than 2,000 attacks per year. for 8,000 ship losses for the last years. So this occurs, of course, over a large population of sheep at risk in summer, more than 900,000 sheep at risk in summer. So this is a big deal, and then the manager has to deal with that, of course. Oops, sorry. And then one can do the scientific approach to analyze this problem. Is first not analyzing only the number of attacks, but where the attacks appear, and also accounting for the distribution of the ship. Of course, if you have no ship, you have no attacks. But if you have 30,000 ships and 10 attacks, this could be appreciated like a large amount of attacks. 10 attacks for one guy is very big, but over 30,000 ships, this is less than 10 attacks over 200 sheep. Okay? So if we account for the distribution of sheep at risk, then we can move to identify some hotspots, here in red, for example. And then once you have focused this hotspot, then manager can get into there and see what is going wrong to try to deter the depredation, the number of depredations. And then the third point is to give some risk analysis with uncertainty. So that's one point I want to show you. As you know, the French wolf action plans include some removal of individuals from the population, legally with a legal killing. And then, to do that, they need to know where the population is going. I mean, if it's increasing, decreasing, and if we can forecast something for the population, if we are removing 1, 2, 10, or 20 animals. So that's what the data of the monitoring are used to model the population. Here you have the estimation of the population size, accounting that we don't see all animals, so this is in the model. And then the population is established at around 300 individuals, but each estimation is surrounded by uncertainty. And this is really important also to say to the manager that every estimation is surrounded by uncertainty, and what is the range of possibilities. That's a really important thing, because no scientist can pretend to say there is a number of wolves without giving a range. So then, with this model, of course, we can include the number of wolves that are removed, okay, legally removed, and try to forecast what could happen for the population, including that number of animals removed from the population. Okay? So then, the management decision has to go on. And then the politics are in charge to do that. I mean, in France, it's the government. And then they have to account, of course, for the population demographic and conservation needs for that protected species. But they have to account also for interactions with pastoral activities with 2,000 attacks. This is really a point to take into account. And also accounting for social and economic constraints. So one of the big parts of the action plan is to give some money to implement different mitigation measures. So basically, this is fencing at night using sheep guarding dogs, also studying the behavior of guarding dogs, how they react in front of the wolf during an attack, for example. This is a study made with the Parc National du Mercantour, with another organism, the IPRA, and also adding additional shepherds to help managing the pastoral unit. So the total cost of the action plan for the last years reached 12 million euros. So this is a large amount of money. So the politics have to decide if he has to put the money here or another place. And then for the other part of the action plan, the government has also to decide the number of animals that can be removed from the population. And instead of giving a number of animals of the wolf population to reach, I mean, we want to have 300 wolves or 400 or whatever. Instead of doing that, because it's always controversial. I mean, it will be always too much for some people and not enough for the other part of people. So to switch off this controversy, there is one possibility that we try to apply is to turn that number into a risk in taking the decision. So you can look here at this graph, look at the red line, and this is the probability that the population may decrease. Okay? If you remove no wolves from here, up to 50 wolves. So of course, the more you are removing some wolves, the more the probability to observe a population decrease is bigger. Okay? So then the manager has to choose about this range. Okay? And then he has to balance between doing nothing and doing too much. Okay? So the last year, the government decided together with the National Wolf Group, gathering all representatives from agriculture, wildlife defense, together with administration. So they are deciding the threshold, I mean the maximum number of wolves that can be removed from the population, knowing the risk they are taking to observe a population decline. So last year it was 36 wolves maximum to be removed. That corresponds to a risk of a population decline of 37%. Okay? That means on the opposite that you have more than 60% of change of the population is increasing, will increase in the next years. So that's how we proceed to help the decision-making process and not focusing only on numbers, because nobody will agree on numbers. But focusing maybe on risk might be better for everybody, because you can choose between a range of doing to balance the risk. So in conclusion, on the French side, as in Italy, the population is increasing and with positive trends, both in distribution and demography. But what we observed after 2 years of such kind of management, the rate of increase slows down from 90% to 60%. So we lose 3 points in the rate of increase, with more area with lonely wolves holding their territories, and also because of the increase in the official harvest. And what we want to do now for the monitoring is to focus increasing the genetic resolution with, for example, trying to get the DNA profile of each individuals. And then as the population increases, we need to increase the number of analyses, and it costs some money. So we have to find some ways to decrease cost and increasing the number of analyses. So we have to find also some alternatives in site survey in area without snow, and this may happen more and more in France, because the wolf is colonizing westward, and there is almost no snow even during the winter. And then finally, we should also account for the ratio between the cost and the benefit to investigate one monitoring system. And of course, if you have too much field effort to give, and that the decision-making process don't need it, I mean, you lose time and money. So you will have to adapt the cost and benefit ratio to state about a monitoring system. So that's what we try to do. Thank you.